Now, if you remember what I told you, I'll be teaching by modules, not by time. And the information I gave the class previously was a one-time information. So if you were not there, you could ask your colleagues, okay? So what am I going to be treating in today's class? Let me start with, so this is STA 111 or 111, and this is the Introduction to Statistics, okay? But in your own, what do you call it? In your own case, it will be called descriptive statistics, right? Am I talking to people? Yes. Good. Please, on no account should you convert a classroom to a church. Is it clear? Do you know what that means? A classroom should not become a church. So it's only a church. You have a pastor preaching and the congregation is silent, will not ask questions, will not say anything. Okay? Yes, so in a class, there has to be liveliness, feedback. So the first thing we are going to be discussing in my class will be organization of data. Okay? We are going to be discussing what? Organization of data. Now, today being the first class on Introduction to Statistics or Introductory Statistics or Descriptive Statistics as the case may be, you don't start a statistics class, as the name implies, introductory what? Statistics. It is in a class on introductory statistics that the student has to be introduced to what? Statistics. So, in introducing you to statistics, it means we must answer the following question. Question number 1, what is statistics? Has to be answered in the class on introductory what? Statistics. Is it clear? Yes. So, at the end of the day, the student should be able to tell somebody or tell one person or the other that statistics is this, statistics is that. And should the person you are talking to have a wrong impression of statistics, it is your class on introductory statistics that should make you know the truth and tell the person your idea about statistics is wrong. You get me? And this is why it is so. So we are going to start organization of data with introducing the students, first of all, to what is statistics. But this will be my module for today. Is it clear? Yes, so, first question is, what is statistics? That's the first question. Okay? Now, I don't know if we should go with I talk, you write, or I write and you copy. Which one? Or we do both? We do both, right? Good. So let's answer the question. What is statistics? Statistics may be considered as a branch of mathematics, because some time ago in the history of mathematics, there was the absence of statistics as an area. Okay? But evolutionarily, statistics has become a separate what? Area. But where it emanated from was what? Mathematics. Now, if you don't want to see statistics as a branch of mathematics, we would say, or a science. Now, the definition is not complete, class. Let me explain. Please, we'll take it one step at a time. Is it clear, everybody? We'll take it what? One step at a time. But everybody must leave this class understanding something. So, now, the reason why this definition cannot stop here, if I come into class and tell you that statistics is a branch of mathematics, question, if I were to be in your shoes, the first thing that will come to my mind is, why is he saying statistics is a branch of mathematics? That's one question. And the next thing is, if I move on to saying that statistics is a science, and I don't use the language that statistics is a branch of mathematics, another question will come into the student's mind. Why is it what? A science. Is it clear? Now, if we now accept, after my explanation, that statistics is a science, or after my explanation that statistics is a branch of mathematics, another question for the inquisitive mind, somebody like me, I will ask you questions, will not be, come on, is statistics a branch of mathematics or statistics is a science? Is that all about statistics? Does it not mean also, if this man stops his definition at statistics is a science or statistics is a branch of mathematics, is there no other branch of mathematics? Or does it mean that every branch of mathematics is what? Statistics. Question number one. And if the man stops the definition there, does it not also mean that if the man says statistics is a science, is statistics the only science? Because if you pick any other science, it would mean calling that science statistics. Is it clear? Yes, so we cannot stop this definition here. It means that there must be something unique, something peculiar, something about it that makes statistics unique or different from every other, what do you call it? Every other science or every other branch of what? Mathematics. Is it clear? Please, I hope I'm talking to people. Yes, good. Now, so let's start with explaining why we call statistics a branch of mathematics. For those in education, or probably in your GSS, somewhere in history and philosophy of science, I don't know if they do it these days, the students should have been introduced to different fields and their history, one of which is mathematics. Now, at the early stages of science, it was simply mathematics. There was no statistics. Is it clear? It was simply what? Mathematics. Now, you know, all of us at one point in time were babies. When a baby is born, the way the baby is born is not the way the baby will be after 5 years. After 10 years, the baby will not be like that. After 15 years, the baby will not be like that. Is it not so? It means that your birth and where you end up are two different moments in time. And time would make room for development. Time would make room for what? Growth. At one point in time, there was nothing called statistics as a separate field. It was well embedded in what is called mathematics. But after its development or its birth came its development, its growth, and eventual maturity, such that it has now gained presence as an area on its own. Is it clear? Now, for that reason, you can consider statistics, since it was born by mathematics, as a branch of what? Mathematics. Is it clear? Even though it has now gained independence and now standing on its own. However, science is a methodological process, a process that follows methods, a breakdown starting from, I think, a scientific guess, right? A hypothesis. And we keep moving like that until a theory is established and all that follows. Please take note. The same methodology in science is the same thing adopted in statistics. Do you get me? So in statistics, all that is done in science is also what? Applicable. For that reason, you can see it what? As a science. Is it clear? Because it follows the principles, laid down principles of what? Science. Now, if we go by establishing statistics as a branch of mathematics and statistics as a science, the question now comes, what makes statistics different from every other science? Or what makes statistics different from every other what? Branch of mathematics. Is it clear? For that reason, this definition is what? Incomplete. Is it clear? So let's proceed. So statistics is a branch of mathematics or science that discusses the collection, organization, that discusses what? The collection, organization, stroke, description. We will regard organization, stroke, description as one thing. Is it clear, everybody? Analysis, the plural form is what I would use. and interpretation of, please, I'm going to put this in capital letters, numerical data, for emphasis sake. Is it clear, everybody? So, if you go home, it means you can confidently tell somebody that aside being a branch of mathematics and aside being a science, is what makes statistics statistics is the fact that we do 4 basic things. Okay? We do 4 basic things in statistics sequentially, meaning that statistics starts at collection of what? Data. And immediately after collection of data, we don't stop there in statistics. The next thing we do is what? Organization through description of what? Data. We don't stop there. After the data is collected, then organized or described, the next thing we do is to do what, everybody? Analyze the data. And after analyzing the data, do we stop there? We don't. We now move on to what? Interpretation of the data. Now, another question comes. Were you to be the one teaching me, I will ask you this. Sir, if you say statistics is a branch of mathematics for the reasons you've given, or statistics is a science for the reason you've explained, that comprises sequentially the implementation of 4 routines. 1 being organization, collection of data. 2 being what? Organization through description of data. 3 being analyzing what? Data. And then 4 being what? Interpretation of. Sir, what then does computer science do? Now, what separates statistics slightly from computer science? That's why abroad, I'm using abroad because in this country, I don't know what is really wrong. Okay? So I have to use the language abroad. If you are a computer scientist, your statistical knowledge should be what? Up there. If you are a statistician, you should be very good computer-wise. And if you are a mathematician, you should be good in both statistics and what? Computer science. Is it clear? But here in our country, it appears to be not at that level. So, our concern in statistics, data to us is what makes, the way we see data in statistics, it's what makes us different from computer scientists. Is it clear? To a statistician, data is basically what? Numerical. In however it comes, it should be brought down to the basis of what? Numerical. That is, by numerical we mean values. Is it clear, everybody? So, the kind of data we handle boils down to what? Numerical data, values. And for that reason, we don't do expressly what is done in computer science or affiliate fields of computer science, just as the one you are in. So, I believe we've been able to answer this question. Huh? Yes, what is statistics? Now, let me ask you a question. Today is an introductory class, so let's be quite free with seeing whether or not, over time, we have been using statistics. Have you been using statistics at home? Huh? Have you been using statistics at home? Tell me how. What's the most common thing you do every day that applies to statistics? You would come to realize that whether you get it from a shop to prepare your food or you get it from the market, you have been using the idea of statistics. Now, statistics is the same thing you do when you go to the market. And I keep telling students year in, year out, I keep telling students the most common example. Why do you think a guy that has a girlfriend, or a man that has a spouse, or a man that has a wife will get angry with the wife over being unable to cook? Now, imagine you being in this situation that you provide the money as a man. It could be the woman providing the money also. Please take note. Let's assume that you provide the money as a man, and that money is presented to a woman who lives with you, who is probably your wife or your girlfriend, and you tell the girl, please, I want you to cook this. And she goes to the market, comes back with the items, and puts everything into a pot without washing them, without cutting them, without separating them. She puts the bunch of leaf like that. What do you call it? All the spices. She puts all of them into the pot and opens it up after it has cooked for 5 minutes and gives it to you. How would you feel? How would you feel? You won't take that, right? You won't take that. Now, because unconsciously, nobody told you that, but unconsciously, probably you've been seeing your mother do it, or you just feel by nature that is how it is supposed to be. Unconsciously, what would make you angry with the girl, evaluating her on the premise that she cannot cook, or what will make you, if you are the girl who provided the man money to cook for you, what will make you angry is you expected that he should go to the market or she should go to the market, get the items. When you go to the market, the first thing you do that is similar to what you do in statistics is what? Collection. Madam, please, how much is your meat? You need meat, you need this, you need that, you need these items to make your food, right? So you go to the market, from this table you collect meat, from the next table you get pepper, you get other spices, whatsoever you need, you get palm oil, right? You gather all the items from the market and bring them home. At the point where you collected these items, they are unprocessed. They are regarded as being raw. Do you understand me? And you cannot use the data you collect or the items you collect from the market in the way they are because they are raw, unprocessed. As such, once you have finished collecting them, comes the next stage. The next stage is what? Organizing them. And while you are organizing them, unconsciously you are describing them. Is it not so? Yes, sir. You will notice that when you bring all the items home, you may want to start washing. Washing the items that need what? Washing. And you would want to pound pepper, keep it one place. You want to open up your knorr cube or whatsoever, put it one place. You would want to pound crayfish and the rest. You would want to wash the leaf and cut the leaf into little pieces you want, the one you want, right? You will do all those things, and unconsciously, when you have prepared those items, all of them cannot go on fire at the same time. They go sequentially, right? Yes. That process of saying you will go in first, after 10 minutes you go in, is a describing or description what? Process. It is still embedded in the what? Organization process. Is it clear? Yes. Now, if you were born in the village or you were born in a town and you have this kind of mother or have this kind of guardian, when your parents start cooking, especially mothers do it very well. Men do not do that. Mothers will cook at some point in time when all the items have gone in. They will now call you, especially the last born. They are the ones that enjoy that promo. The last born, they will call the last born, come. Because of the smell and everything you've taken in as the mother, your nose may be confusing you, right? So you will call somebody else, scoop a little bit of the water in that soup, if it's a soup you are cooking, and put in his or her hand and say, test, right? Yes. You say test. What do you think test means? Analyze. The testing means, let's see, questions in the testing process is there much salt or much knorr cube or Maggi, as the case may be, right? Is there much pepper? And as you are testing, your brain is processing, telling you there is more of this, there is less of this, there is more of that, there is less of this. And why do you think the analyzing process is important? The analyzing process directly links up with what? The interpretation process and helps decision making. As soon as your brain, you test and your tongue sends signal to your brain and tells you that there is much pepper, the next thing that will come into your mother's mind, once you tell your mother, mommy, there's more pepper in this thing, the next thing that will go to her brain will be add more oil or add what? More water. Is it not so? So these processes, the process of collection, the process of organization through distribution, the process of analysis, interpretation, help statisticians recommend good decision to the general public. I hope you understand. So statistics is not as useless as we think. Next item. Now, that being said, let's now answer this question. What is a field? Are we there? So, in my explanations, I talked about going to the market. Is it not so? Going to the market. I talked about going to the market. Remember, I said I'll be teaching you guys by module. Now, going to the market to collect items. When you go to the market to collect items, you call the place you collected the items the market, right? Statisticians go to places to collect data. We don't collect food items, we collect what? Data. Now, what do you think we call the place where we collect data from? It is called what? A field. Do you understand me? So, simply put, a field is any place or space where data is collected. Okay? So where do we collect data from, guys? We collect it from what? A field. Good. Now, next question is, what do you call it? Let us now come to, now you would see, what does our topic say? Organization of what? Data. So, let's now answer the question, what is organization of what? What is organization of data? So, we will put there organization of data refers to every and any process that converts data from its raw or unprocessed form to its processed form. So, please take note. I was expecting a student to ask me the question, why are we skipping collection of data? Why are we skipping analysis of data? Why are we skipping interpretation of data, but putting our focus on what? Organization of data. Now, two reasons, everybody. Number one, the reason why we are skipping collection of data is because of the scope of this course. Is it clear? The scope of this course excludes collection of what? Data. It also excludes what? Interpretation of data, but borrows a little from what? Analysis of data. Is it clear? That's number one reason. Number two, statistics is very broad, such that there is an area of statistics that is dedicated to discussing that aspect, collection of data. We call it sample survey or sample survey techniques. Is it clear? So our focus excludes what? Collection of data, and we will begin our discussion and dwell on that, which concerns what? Organizations through description of data. Now, so When we organize data, what are we trying to do? When you tell somebody you are organizing data in statistics, it is, simply put, the conversion of data you collected from the field, which is unprocessed, to data that is what? Refined or processed. Is it clear? So we will make a remark here. Note that data obtained from a field is called raw or unprocessed what? Data. Data collected from the field is called what? Raw or unprocessed data. Are we there? Good. So please, can I wipe this off? Good. So please ask. Yes, what's your question?
Okay, sir. Okay, sir. Now, please,
Sit down.
I understand what you said concerning the meaning of what is statistics, how data are going to be from using explanation of the matter.
Yes.
When we're going to So, talking about data here, I don't know how data can be formed. How, like, in what manner can we say this is numbers or this is data in computer or in terms of statistics, not referring to the market?
Okay. Now, your question has an answer in time. Do you understand me? Such that when we pass by your answer, you will say, oh, that's the answer. Is it clear? So the answer is where we are heading into. Huh? So now, let's now move over to the next item. So let's go with types of data. Are we there? Please, am I too fast?
No, sir.
And I hope I'm not talking to myself. Oh.
No, sir.
Good. Now, let's go to types of data. This class would end somewhere not too far from here. But please, my emphasis is on understanding. Okay? Now, types of data. If you are going to organize data, then we've already clarified that the data we are referring to is called numerical data, right? What kind of data are we dealing with? Are there categories of data or types of data? What categories are there or what types are there and what are they? So, data may be classified. Data may be classified as being let me put it this way, A, discrete, B, continuous. Are we there? So let's put it this way. Data may be classified as being A, discrete data, or B, continuous what? Data. Please, I hope everybody is following. Yes, that's my primary interest, so if not my only interest, that's my interest. So, if data to us can be discrete or continuous, the question now comes again. What or under what circumstance is data what? Discrete. And under what circumstance is data what? Continuous. Huh? So, let's now move over to the next thing. If you must organize data, then you should know what data is all about. Is it clear? So, don't think because we are talking, because the question may be, if our topic is saying organization of data, I think this man should be showing us the processes. How come is he talking about some other thing? See, I love the women so much. Women don't just say or do makeup and pour everything on their face. You do makeup, right? You do makeup. When you see them during weddings, birthday, you do makeup. There are scanty women in this class. You also do makeup. For now, you have not started yet. You have not started yet. Very soon. The way you guys come in at 100 level cannot be the same way. Now, you can never be. By year 2, 200 level, 300 level. So for now, this is the only time you can catch them very humble. So, now why I'm saying this is that you don't just apply makeup by pouring everything on your face. Is it clear? For you to bring out that beauty, the way you really want your face to be for an occasion, you have to put it one after the other, one after the other. You have a target. The target in this case is organization of data. And for you to organize data, you need to explain this. You need to put this makeup. You need to put that makeup. You need to put this makeup. And at the end of the day, what we will now see on your face is organization of what? Good. So it's the makeup we are putting. Now, so since we have said data can be of two types, discrete or continuous, let's now go to discrete. Discrete data are, please take note, data is, what do you call it? Plural, okay? Datum is what? Singular, one. So discrete data, and in some contexts, people see data as being plural and as being what? Singular. Yes. Datum. Yes. D-A-T-U-M. Now, some people, I can tell you, data is plural, data is what? Singular. Some people use datum for singular and data for plural. So we would use them interchangeably, okay? So discrete data are data obtained by counting. Okay? Discrete data are data obtained by what? Good. Now, please look up, everybody. To statisticians, everything will boil down to what? Numerical data. Now, in this class, going by the columns, you see it. This can be regarded as column 1. There are 4 columns in this class. Okay? Column 1, column 2, column 3, and column 4. If a statistician comes here and is asked to give a summary of how the students were arranged in class, he may choose to classify the students into 4 groups. Group A, B, C, and what? Now, if you now ask him, how many persons are in group A? What would he do? He would have to do what? Count. And at the end of the day, he will get a numerical value for group A. Do you see it? So at the end of the day, that description of the class would amount to A, B, C, and D, giving values like 17, 19, 22, and 14. Do you see it? Now, the question that helps us as statisticians classify those values under discrete or continuous, under what kind of data, depends on how the data was what? Collected. So question is, how did he collect that data? For group A, B, C, and D, he collected that data by doing what? Counting. And because that data was collected by counting, it is regarded in statistics as being discrete. Is it clear? So discrete data will give you values. Continuous data will give you values. But what separates them into discrete and continuous, or discrete or continuous, is depending on what? How they were obtained. Is it clear? If I tell you go to the VC's office and get me the types of cars, there may be, okay, the predominant types of cars. If you go to that VC's block or all around the school, you may separate cars into Toyota, Benz, or what do you call it? Nobody uses Passat, God forbid. Passat. You may just take all the types of cars. Okay, car type A, car type B, car type D, car type C, up to car type F. or so. And if you count all the cars in that group or in that type, it will give you a value. Is it not so? Now, if you want to go to a department also to know the number of students in the faculty, when somebody tells you, give me the number of students in the faculty, they are never satisfied with you telling them that there are 500 students in the faculty. They want to go down that level to say, okay, if there are 500 students in the faculty, if this is faculty of physical sciences, how many students are in mathematics? How many are in statistics? How many are in this? All those values, you must have gotten them by what? Counting. So when you obtain data by counting, that data is referred to as what? Discrete. Examples of discrete data, please. Examples of discrete data. Examples of discrete data are one, number of car types in a parking lot. 2, number of book types or discipline in a library. 3, number of persons in a society by age group. 4, number of different fruit types in a fruit market, etc. So, one thing that is common to all of them that I have mentioned is the fact that all of them here, if you go to a parking lot to know the types of cars there, you will count. Am I right or wrong? If you go to a library and we say, help us tell us as a student the number of disciplines where books are found in this library, you may go here and say, I have seen computer science books, I have seen mathematics books, I have seen biology textbooks. Is it not so? And if we want to know how many you saw, you will obtain that value by what? By counting. So those are good examples of discrete data. Now comes continuous data. If discrete data are data obtained by counting, please take note, guys, that continuous data are data obtained by measurement. They are data obtained by what? Measurement, or in an interval. In an interval of values. Full stop. Again, don't leave this class as if you came to a church where anything said is yea and amen. No, everything written on the board has an explanation, which is logical. See, if I tell you now, do you count your age, or age is measured? You count it. Okay, do you count your weight, or your weight is measured? Huh? It is measured. So if I ask you a question, how tall is that guy? What will come to your mind if you don't know, but you are really desperate to give me an answer to that question? You will think about, let's measure this guy's height. Is it not so? How thick is this guy? What's his weight? Your mind will go to, let's measure. If I ask you, how old is this guy? Where would your mind go to? Measure or count? Count. Good. You now see that somewhere in this bracket is the statement or in an interval of what? Age is not considered as discrete data, even though it appears as something you count. Do you get me? At what day will you say you are 16? At what day? And if it is on July 5th, 1996, I'm just giving an example, that you become 16, even in that day, at what time were you 16? At what exact time? When we sing, happy birthday to you, happy birthday, the person wakes up in the morning of the birthday, is it not so? And they say, oh boy, today you are 16. Oh boy, today you are 20. Oh girl, today you are 17. Is it not so? The question is, at what exact moment did the person clock 17? You will realize if you, now everybody will start bringing their reasoning. Is it not so? So to save you the stress, age at every point in time is always within an interval of what? Values. Because if the exact moment you are born was 130, you should be 130, it should be 130 on the day you celebrate your birthday. That's the day you can actually, that's the time you can actually claim you are what? 16. But that 16 that you are will pass by so fast that it can only happen in a twinkle of an eye, such that after that throughout that day you'll be 16. I hope you know. You'll be 16 years, 1 second. 16 years, 1 minute. 16 years, 1 hour. 16 years, it will keep going like that. So age is always found within an interval of what? Values. Now, if I come here and I stand on a, let's say there's a measuring scale here to take my height. If I stand here, what you will see here maybe 6 feet. But that 6 you see lies between, to start with, 6 lies between 5.9 and 6.1. Am I right or wrong? 6 lies also between 5 and 7. Is it not so? Yes, sir. So the same 6 lies between 5.9999999 and what? 6.0111000000001. The same 6. It always will lie within an interval of what? Values. So also is weight. So weight, height, age, all of them are usually classified as what? Continuous data. Simply because they are either gotten by measurement, not by counting, or they are either found in an interval of what? Values. Is it clear? So, examples of continuous data. Quickly. Examples of continuous data. Examples of continuous data. 1. Are you writing? I hope I'm not breaching the agreement. Remember we said we will do both. Is it not so? So, examples of continuous data are 1. Weights of babies born at a maternity ward. 2. Height of students in 100 level information system. 3. Ages of students in a classroom. 4. Masses of objects in a container, etc. Are we there? Please, are we there? Now, I'm now entering the last component of this class. The last thing I'm going to say in today's class is now methods of organizing data or techniques for organizing data. So now that we know all this preamble, question now is, what are the techniques available for organizing data? So we will now come over here and say techniques for organizing data. So we say data may be organized using 1, graphical techniques. Graphical techniques, okay? Or 2, frequency tables. Frequency table. Now, please take note. If you don't want to call these frequency tables, we call them frequency distribution. Now, it will be very funny to say frequency distribution table. It is either you call it a frequency distribution or you call it what? A frequency table. So, this is where we shall end our class, and I'm going to end on this note. Number 1. So we are going to start from here on. This will give birth to almost everything that shall follow in our course. Is it clear? So we are going, in this class, I'm going to stop the class with mentioning all the graphical techniques we shall be looking at. Okay? And I'm going to also explain the frequency tables and what do you call it, that we shall be looking at. So let's now see graphical techniques are often used for organizing data. Graphical techniques are often used for organizing data in a more pictorial or visual form as compared to their frequency table counterpart. We shall consider the following excuse me. We shall consider the following graphical techniques. We shall consider the following graphical techniques in our discourse. Not our discussion, no. Or that's the spelling of my discourse. Okay. So now the semester is so short that we cannot go through all the graphical techniques available, but we shall select the ones we shall treat. Is it clear, everybody? So graphical techniques are often used for organizing data in a more pictorial form, pictorial or visual form. Okay? Now, there are some people, the reason why we accept the use of graphical techniques. For example, most of you, when you graduate, God bless you, you may end up becoming very, very good presenters. And People consume statistics not with numbers all the time. Some people prefer absorbing things or understanding things using diagrams. Okay? So, graphical techniques will help in that regard. Now, let's now mention, to end this class, the graphical techniques we shall be considering in our discourse. Number one, we shall be looking at bar charts. Or let's start with pictogram. There is a graphical technique called pictogram. We are going to be answering the question in this class, what it's all about. How does it look like? What is it used for? When can we use it? When do we not use it? Okay? Number two, bar charts. Now, here we are going to be looking at the types of bar charts available, how to set up a bar chart, what is a bar chart, and all those questions. Then comes number three, we'll be looking at line graphs. Line graphs. Number four, we'll be looking at pie charts. Number five, we will look at histograms. Or before then, preferably, we will look at box plots. Number six, we will look at histograms. Number seven, we will look at frequency polygon and frequency curves. Number eight, we will look at, please pronounce this. It is pronounced in this manner. Ogive. Not ogive or ogive. It is ogive. Another name for it is cumulative frequency curve. Then, it will be unfair of me if we don't conclude our discussion with this one. This is the one I really am interested in. Stem and leaf plots. So, these are some of the graphical techniques we shall be looking at. I pray we are very fast with dealing with them. Okay? So we shall be looking at these graphical techniques. Once we are done looking at these graphical techniques, our eyes will now go to the next part. Remember, all these graphical techniques are techniques for doing what, everybody? Organizing data. And once we can discuss them, practice them using data, I will show you how to do them. We will now come over to what? Frequency tables. Okay? When we finish discussing frequency tables, we are done with the topic organization of what? Data. So organization of data is our topic what? 1. You see how far we are. So once we are done with that, we are done with topic 1. We will now move into topic 2, which is what? Measures of central tendency. So it was nice being with you guys. Thank you very much for being attentive.